So all I was just saying is that if you take this, or rather, let's not take any example. A1 starting with A1 and A2, and this goes with, let's say, common difference, D1. And so I'm not writing the number, like we already had numbers in the previous example, 1 and 7. And let's say that if you're already told that these two are equal, then can't you just go down in the sequence and simply just write this thing, right? Then why cannot I write just D2 plus D1? I mean, I just take D2 more steps, right? I come here, and here also I will take D1 more steps, D2 time, D1 steps of length. I mean, each time I'm, it's a D2 size step. And so if these two are equal, these two also better be equal. And this is obviously there in the arithmetic progression, right? Is it clear that it is also there in the arithmetic progression? Right? From here, you take D1, D2 more steps. Is it not clear? This term is also in the first arithmetic progression. That's the first question. Is that fine? Yes. If yes, then also please say, is it? Oh, am I not audible? Okay. Is there something I need to allow us to unmute? No, I have not put anything restriction. Are others able to unmute? Oh, something is wrong. Enable waiting room. Yeah, it's I have disallow and allow again. Yeah, you're free to unmute. You're free to start your video. Anything. Are others able to unmute? Just tell me. Just unmute and.
Yes, sir.
Okay, so then it's Nagesh. It's his problem then. Okay, so Nagesh, others are okay. He's joining. So, but then tell me, do you see that this will also be in the arithmetic progression? A1 plus N1 D1 and then D2 times D1 also if I add, that's also there in the arithmetic progression. No? See, I mean, if you starting with 1, and let's say you're taking 1, 2 times 7, right? And let's say you did, so last time we did 4 times 7, right? Okay. And then from here, you can do 1 plus 4 times 7 plus 7. Well, you're taking steps of 7. That's basically 5 times 7. Can I not do? I mean, I can add 7 in any way, right? I don't have to factor it with that. It doesn't. That's the same thing. I can do 9 times 7. I can do 10 times 7. You know, this is basically just 13 times 7. Okay, so I can do this, right? I can add any number of multiples of D1. That's the whole point of being an arithmetic. So this is there in the arithmetic progression, okay? This is basically A1 plus N1 plus D2 times D1. So now it's officially there, right? Yes, N1 plus D2 steps. Similarly, this is also there. And obviously these two are equal because these two are equal. You just add D1, D2. That's the funda. It's very, very simple. So you have to just add. So the first arithmetic progression is taking steps of D1 and the other one is taking steps of D2. At some point, if they become same, then you take D1 steps for D2 steps for this, then D1 plus D2 will get added. And you for this the other one, it takes steps of D2, so you take D1 steps. Yeah, this is also equal. So you take d1 steps of this, then d1 plus d2 will get added, and so they'll remain equal. And then again you take 2 times d1 d2, right? You can add. So is it fine then? Yes.
Should be N2 D2 in the second series.
Yes, that's wrong. Yeah, that will be n2. That's right. This will be n2. Yeah, that's a good point, because yeah, through this term we are going to add d1. Okay.
N2 D2.
Oh yes, it will also be d2. So that's certainly, yeah. I just copied that. Okay. All right. Okay. See, basically this is like a. So does anybody see the similarity with this and the other case? So I mean, I don't know. You guys are not saying Satya and Nandini, like, I don't know if this clear, making sense.
Yeah, it's making sense now, sir.
Right?
Yes,
Okay,
sir.
good. Now you see, this is basically not different than the previous first case, the easy case. See, the general principle here is that, and this is just a common sense. I guess you guys already know it, but I'm just saying. I mean, if you cannot solve a problem, solve a simpler problem. Just simplify the question. So earlier, when you simplified the question, you had a1, a1, and you said, okay, a1, a1 is matching. Then you take a1 plus, suppose the common difference is d1, so you take d2 steps, and here you take d1 steps, and they become equal, right? So you're starting with two terms being equal, and the arithmetic progression is starting from there. With first one has common difference d1, second one has common difference d2. How is this problem any different? I mean, here also it is as if you forget these, and this is the starting point, and this is also the starting point of two arithmetic progressions. First one has common difference d1, second one has common difference d2. This is the starting point. This is the new a1, and this is the starting point, and the common difference is d1 and d2. Starting point is same, right? They match in some place. You can just begin. You can take it as if they are beginning from there, and so beginning point is same, and so they will keep being same, because we already did that. Okay, arithmetic progression is like that, right? No matter from where you start, it's again arithmetic progression from there. All this is common sense. Okay, all this is not going to be officially written in your books, right? It might be, it's good maybe if it's written, but this is just the common sense things you have to use. It's beyond the formulas. It is as if the arithmetic progression is starting from there. You could take any point in arithmetic progression, and from there you can start your arithmetic progression. So it just reduces to the previous case. So you can do it like that. So then it is. So that was this one question on arithmetic progression. Yeah, so about the solving, maybe let me not say about that now. Okay, that will get a complicated, then we'll digress into a different direction. Okay. Now let's then keep doing with this theme only today. Maybe this is going to be all small, simple questions, so nothing to be about. Let's do this. Now I'm again writing everything in words. We have to then unpack it and let a1, a2 dot be a sequence, okay, so that difference of any difference of, I'll just say, should I say any? Yeah, difference of any two consecutive terms is or I'll just say difference of the consecutive terms, difference of the consecutive terms is an AP. Okay, is an AP starting with 2 and five. Okay. Find 100. So a lot of it is only unpacking. Otherwise, the question is very simple. First, try to unpack it yourself. This was a theme somewhat it came up. It's something that you guys already know. When you unpack it, you'll see that you already know it. And second is it came in the partial fraction in the telescoping business once. Let's So I have not told you the first term. Maybe I should say the first term. So let's say that the first term is, you can take it to be 1. It doesn't matter. So the first term is 1. So try to unpack it. Try to understand what this is. And how would you do? Would you want to just look and understand? If you can do that, it's good. Or if you can just write the terms and see, that maybe is the way to go for you. It's up to you. Write it, write the terms and see what happens. It is 1. So what's the next term? What's A2?
Next term will be 1 plus d, right?
No, it will be no, the common difference is an arithmetic progression. So you have to unpack that. So let's see. So if it's, let's say the second term we don't know is A2. Let's say it's A2. And let's say this is A3, A4, A5. So did I say common? So not common difference. This is the point. This is not an arithmetic progression, right? The difference. I'm not saying common. The difference is not common, right? The difference is changing. All I'm saying is that the difference between these two terms, officially I should write A2 minus 1. And I'll just write is 2. because that the difference. So if you take this difference and then this difference here, I'm going to write the differences. That forms an arithmetic progression. So the wording of the question is a little ambiguous, but it's enough to interpret it, in my opinion. Okay? So the first two terms, the second minus the first term is 2. Third minus the second term is.
Oh, so now it will form 2 plus 5, right? Because common difference of 5.
Yes, exactly. The difference is an arithmetic progression. And so the differences will form an arithmetic progression. And as you said, it is 2 plus 5. And then it is 12. And then again plus 5, 17. Okay, the question was little ambiguous, but you have to interpret the natural meaning of it. That I'm taking the consecutive differences, I'm taking the consecutive difference of the consecutive terms, and that is forming an arithmetic progression. Is an arithmetic, because the differences also form a sequence. So now tell me what should be, so what is A2? Now there's nothing to do, right? It's just 3. And this is 3 plus 7, so that's 10. All of this is good, but then what is the 100? Are we going to compute it and explicitly know? How do we know? How do we know what is 100? Also, some problems from last time are also pending, so we have to do them.
Yeah. So it's 1 plus 2 into 5 minus 5 into n minus 2, right? 1 plus 2 plus 5 into n minus 2.
No, that is not. That will be the common. That will be the difference. The difference here may be somewhat like that, but the terms are much faster, right? Is it just that? Is it just 1 plus 2 plus n minus 1 times 5? No, this is not the term. This will be the difference between the, whatever, nth term and n minus 1th term. You see, this is not correct thing. So the hint is sum of arithmetic progression, sum of terms of an AP. I'd said that it's a passing remark at one point, but anyways, is related. It is basically that problem. Okay? And remember, all your questions that will come in the exams and all, they will mostly be from elementary. There's nothing advanced techniques you need, but you have to interpret it correctly. You can see, right? What is A2? A2 is gotten by 1 plus 2. That's what it means that A2 minus A1 is 2. Look at A3. A3 is gotten from A2 by adding a 7. So what is A3? 1 plus 2 plus 7. What is A4? 1 plus 2 plus 7 plus 12. That's how you come to A4, right? By adding those differences. That's I think, is that making this fine? Just saying in just layman's words, right? How do you get to A4, right? You take 1, then you add 2, you add the differences. Right? You take 7, you take 12, then you come to A4. So how would you come to 800? By adding all of this, you'll come to 800 with a 1. But you have to explain this in better words, maybe. But is the idea, am I able to say the idea correctly? Am I able to get through like this idea that I wanted to mention? Yes or no? The nth term is sort of adding. Okay. So try to, all this, one doesn't have to really think of it so much, in the sense one can write a recurrence and then, write this as a recurrence. But I assume you guys are not so far very comfortable with it. We'll do this problem from recurrence angle also. And by doing only, you will get comfortable. There is no, so this is one. Let me give you guys 2 more questions and you ponder upon them. It will take some time, but try. So yeah, this week I'm not giving any, I mean, I never give too many problems because see, this is like a, for like you do a few problems, but you spend more time on them. And then I leave you up to you guys to try from in number of the tests. Okay. So yeah, this week, let me, and then you keep doing the, have you done the arithmetic progressions thing? Did you practice? Did you
Yes,
get the
sir.
time? Good. So you got the time to practice it. Very good. So just try the next sections. Okay. So next section would be sum of arithmetic progression. Get to the miscellaneous questions there that you will find really interesting. If you're finding it boring, then you go to the miscellaneous section, you'll find it more interesting. Okay. I want you to get comfortable with this arithmetic progression and so on. That for that you have to just do the practice. Okay. So you do that, but on top of this, some problems from last time and problems this problem, and then just 2 more problems, and then I'll leave, or maybe 3 problems. Let's see. Here is a certain thing, and we have done a question like this. So given this will be interesting, I hope you'll enjoy this. So all these are just based on the ideas from before. Okay, given that there is a sequence in which you have something like this. So you have an plus an minus 1 plus an minus 2. So don't just don't get afraid of this. You can just write the terms and then you will see the patterns. Okay, this is just to make the question short. I mean, all of this is just like, okay? I mean, and this is how you will have to deal with things. And this is a much faster, effective way you will see over the time. This is given. Okay, you can take that. I'm not too much concerned about that, but you can take some terms and take it to B2 and A3 to B3. Again, I'll keep the question very crisp, but it's up to you. You may have to investigate a lot of things, but I'll just ask, I mean, you may have to investigate various things. Find A100. Do not be so surprised. Do not be very surprised because we did a question like this where it was sort of, we had this. Okay, maybe one term was on the other side. You see, eventually it was like this, right? And we got some good sequence, which was some, repeating things and so on. Try this. This is one. And the second is, now there are 3 APs. Okay. So this A1, A2, A3, B. I'm using letters for the APs themselves. These are not terms. These are just the arithmetic progressions. B3 APs. This is just so that I can refer to them easily for the rest of the problem. That's just for me. For you, you can write the terms, everything. That's for you. B3 APs. Okay. If A1 and A2 intersect, okay, I mean, A1 and A2 have a common term. That's the same thing as intersecting, right? Have a common term. A2 and A3 have a common term, and hence they have infinitely many common terms. All this we have proved. Have a common term. Then will, and I'm just asking. I always ask the question. I don't say anything usually, right? I'm not very precise. I'm saying then will they have, and it's up to you. You try examples and see whatever you can do. Then will A1 and the question have a common term? These are just natural questions that comes to just curious mind. It can just come. Maybe it will won't come to you guys now because maybe you get comfortable, but you'll see over time these questions will come. And already for the concepts you would have learned earlier classes, some questions strange maybe at first questions would come, right? You spend time thinking about maths for its own sake. A1 and A3 have a common term. And this is a question. I'm not saying yes or no. You have to think or just try and see. So these are the 2 questions. These are 2 questions. I want to say one more question. I forgot. There were some questions. Yeah, I forgot. So let's see these 2 questions. Okay, but think, and obviously there was one question before, or maybe one question. Okay, so that's it for today, and yeah, so meet next week for this topic, and the other classes are as usual. So Okay, so for the polynomial, so the number theory class tomorrow is usually at 4 and so 4:15, so it will be at 4:15. Okay, and for those who are doing it, and the polynomials class is usually at 9, so it will be at night. Those are just aspects. Okay, and then we will meet with you also next week. Spend the time in solving, practicing everything.
Oh, sorry. When is the polynomial class tomorrow?
Yes, so the polynomials class is usually at 9, right? 9 p.m. IST. Is that correct?
Oh, yeah. Yeah.
So it's just as usual, and it's usual. And 4:15 is the, I don't know if you're doing a number theory class 4:15. That's also as usual. Okay, so then see you. Yeah. Okay. Bye. Thank you.
Thank you, sir.